Okay, now that your quick check is done, we're going to move on and we're going to take a look just a little bit today into lesson 6, which is solving proportional relationships. So you should have lined paper, your notebook or loose leaf, it doesn't matter. You should have your pencil. You can have your calculator as well because we will use that. So the first thing that you did was actually take a peek at a video a few minutes ago on equivalent ratios. And it gave you an idea of how you find if you have equivalent ratios, what makes them equivalent. And so in the video, it talked about how if you check cross products, that gives you equivalent ratios. Well, that leads into the word proportion. And so we keep using this word proportional, and you see it so far in every aspect of this chapter. And so, what is a proportion, and what does that have to do with equivalent ratios? So, on your paper right now, I would write this, what you see on your screen. And let's talk about what a proportion is. And anywhere along the line, as we're doing this, you can pause the video to take the time to copy what you need to. So let's define this. What is a proportion? So a proportion is an equation. And you are going to have to really forgive my handwriting on this because I'm using a board and a pen, and it's not the same as writing on an actual piece of paper with you guys. So it's going to look not great. And so I'm going to apologize ahead of time. I'm going to do my best I can so that it's definitely legible, but just realize it's also a little tough to write on this pad that I'm using to give you notes. So it's an equation stating that two ratios are equivalent. A proportion is an equation stating that two ratios are equivalent. Fabulous, because the video that you just watched showed when you had two ratios that were equivalent, how you got it. You checked their cross products, and guess what? It's called a proportion. So let's actually try a little bit. Let's talk about these cross products that you just saw in the video and see if that makes sense to you. So I'm going to actually turn the page and let's try some examples. So the first one I'm going to give you is 6/8 equals 3/4. And I want to know if this is a proportion. And so I can find out if it's a proportion by checking the cross products like you just saw in that video. So I can take and multiply 6 times 4 and get 24. And I can multiply 8 times 3 and also get 24. And if they are equivalent to each other by checking cross products, then you have a proportion. So I'm going to write yes. That's a proportion. Okay, let's try another one. Now, cross products is definitely one way that you can do it. I'm going to show you a different way also to see if you have equivalent ratios and if it's a proportion. So what if I wrote 1/2 is equal to 3/6? And I'm still going to ask that same question. Is this a proportion? Not using cross products. I want you to think about this. So how many times larger is this numerator getting right here from 1 to 3? And also, how many times larger is this denominator getting from 2 to 6? Well, from 1 to 3, isn't this getting 3 times bigger? And then from 2 to 6, isn't this also getting 3 times bigger? So both the numerator and the denominator are increasing by the same size. And so if they're increasing by the same size, this is also absolutely considered equivalent, and it's a proportion. So there's really two ways that you can do it. You can check two ratios with their cross products and see when you multiply across if they are equivalent to each other. Or you can do what I just showed in example number 2, where when you look at the two ratios, you can determine how much larger, and in some cases, you might look at how much smaller it's getting. And if it's by the same amount, yes, you have a proportion. Okay, so let's try a couple more. Oops. All right, so I'm going to give you a couple more examples. And I'm going to let you decide on your paper how you want to determine if they are a proportion or not. So I'm going to give you this time 1/2 again equal to 4/7. And I want you to be able to tell me if this is a proportion. Are these two fractions or two ratios equivalent to each other? Check cross products or see if it's getting a certain size larger or smaller in the numerator or denominator. So you're going to try this one and tell me yes or no if it's a proportion. And then I'm going to have you try here another one. So if I gave you, let's say, I'm going to go a little bit larger numbers here, 7/8. Is that equivalent to 35/40? Same thing. I want you to tell me if that's a proportion. Either cross products or check to see if it's getting a certain size larger or smaller. So you're going to pause the video, try those two right now, and then when you're ready, you'll unpause and check your answers. Okay, let's take a peek. So the first one, I checked cross products on that one. I was looking to see if 1/2 is equivalent to 4/7. And when I checked cross products, I did 1 times 7 and got 7, and 2 times 4 and got 8. And they're not equivalent to each other. So if they're not equivalent, then that is not considered a proportion. You do not have equivalent ratios there. The second example, I was looking to see if 7/8 was equivalent to 35/40. And on this example, I checked to see how much larger it was getting in this case. And it's getting 5 times bigger in the numerator and 5 times bigger in the denominator. So yeah, you have a proportion there. Those are absolutely considered equivalent ratios. All right. So let's take a look at some more. And I'll do a couple more with you, and then I'm going to give you quite a few more examples for you to try. So let's say I did 4 over 6. And I want to know if 4 over 6 is going to be equivalent to 20 over 18. So let's say I try deciding if this is getting larger by the same amount, top and bottom. So if I'm looking at going from 4 to 20, well, that's making it 5 times bigger. But in the denominator, if I'm going from 6 to 18, that's only getting 3 times larger. So right there, both the numerator and the denominator are increasing by different sizes, so not a proportion. You can, right? So I'm going to write or. Always check cross products as well, right? So if I just rewrite that, 4, 6, is that equivalent to 20 over 18? And I use my calculator and I multiply these, 4 times 18 and 6 times 20. Well, 6 times 20 is 120. And if I do 4 times 18, I get 72. So here again, this proves just by showing our other way, which was cross products, that these are not equivalent to each other. So in either possibility, the checking to see how much larger or checking the cross products, you have proven this is not a proportion. They are not equivalent ratios at all. All right, so like I said, I want you to try some more. So I'm going to list some more problems here. And we're going to take that off. And I'm going to give you quite a few to practice. So as I write these in, you're going to write them on your paper. And you're going to check if these are equivalent and if they are proportions. Okay, so there's 6 of them there. So those 6 ratios determine if they are a proportion. Again, when you think you are ready and you've determined your answer on those 6, then you're going to we'll pause it right now, and then you're going to unpause the video when you're ready to check. Okay, take a look at those 6. Now, if you didn't, in let's say the first example, check to see how much larger it was getting, and you did cross products instead, that's fine. You would still get the same exact answer. Or like in my fourth example, instead of cross products, maybe you checked by seeing how much bigger, and that's okay too. So once you've checked your work here, the next thing that you're going to do is take a look at some directions for that quiz on the agenda. And then that will be your time remaining for the rest of the hour.